All right, students, let's begin. And we're going to see how quickly we can get through this lesson. This should be exciting. Yay. All right, so today we're going over 2 lessons, and the lessons are going to cover more of an introduction to these 2 different topics. The first one is from section 7.7. It covers transforming formulas. Now, everything we're going to do is old school math today. It's all old math, but you're going to see a lot more letters involved. We're doing the same steps, it's just that the letters are involved. And when letters are involved, you can't actually do the simplifying part of the math. But we can still go through the motions of adding and subtracting with letters, okay? So it might be a little weird at first, but when you just really take a look at it, and you'll say, okay, it's not that different, it's just, it's not difficult. It is different. It might be weird. You might just think of it as weird. But you should be able to understand it still, okay? And you need to know this because this stuff will be on your test coming up soon. So, all right, the first one is solve the area formula. So this is the formula part. We'll be giving different formulas. So solve the area formula, which the area formula is A equals the length times the width. So LW. And we're told to solve it for W. Now, all of these, you're going to be told to solve something, a formula, an equation, and you're going to be told to solve it for one of the letters. Now, all that means is you've got to get the W by itself. It's kind of like over here. This formula has already been solved for A, because the A is by itself. So if I ask, so what does A equal? You could say, well, A is equal to LW. Okay, well, what does W equal? Well, I don't know what the numbers are, so I can't tell you. No, but you could tell me what it is equal to in relation to this, and here's how. Get the W by itself. So think of it like this. If L was some kind of number, and I had some number W, and they're touching like that, how would I normally get rid of it? Dividing, which is what we're going to do. So go ahead and write down the formula again right here. Say A is equal to LW. And so I'm going to divide both sides by L. Divide both sides by L. So what I end up with is W is equal to A divided by L. And this is what I was talking to you about, the whole, well, we can't simplify it. What I mean by that is you can't tell what A divided by L is. We don't know. They're not numbers. They're letters. So we just basically stop there. That's it. So it's almost like you stop halfway. It's like with the numbers, you could take that last step. With the letters, you can't. So you got to leave it basically halfway done. It's, kind of like that. But that's the final answer. It actually takes less work to do these kind of problems than it does the normal problems. You just need a little bit better understanding to solve it. All right, next problems. All right, here we have solve P is equal to S minus C for S. So I'm going to write this down. P is equal to S minus C. And I want the S by itself, so I'm going to have to get rid of the C. Well, how do I get rid of minusing some number? If I was minusing a number, I would just add that number to both sides. We're going to do the same thing because C is just like a number. So we're going to add C. Well, that gets me my S by myself, but what is P plus C? Well, do I know? Well, no. If you don't know what that equals, then you just write it back down as you say it. P plus C. P plus C. And that's the answer. Okay? Once again, I know, weird, right? But simple. Literally, that's like if these were numbers and this was like a 5 plus 3. Instead of writing 8, we just write down 5 plus 3. You just stop. It's like freeze before you take that last step. That's all we're doing. Next, we have, this is the perimeter formula. You guys should recognize it. And we're told to solve this formula for W. Once again, we're solving for W. So we could copy this down. I'm going to copy down right underneath it, just because I feel like it. And now I'm going to say, well, I need to get rid of something. So I have this 2 L's in the way, and this 2's in the way. Well, I get rid of my constant first. So I get rid of this guy that's not touching the variable that I want to get by itself. So it's almost like whatever you're trying to solve for, treat that like x. Everything else you can treat like a number. So we're going to subtract 2L from both sides. Now this is a two-step problem to solve, so it's going to take a little bit. So now I have P minus 2L, because remember I don't know what that is, equals 2W. Now I need to divide. So I would divide by 2, divide by 2. Well, if I divide this by 2, what I end up with is, you can say like P divided by 2. So that's P divided by 2 minus, what's 2L divided by 2? Well, the 2's cancel out, leaving you just with L. So you have P divided by 2 minus L is equal to W. And that's your final answer. If you want to reword it or rewrite it so that the W's in the front, that's fine. Just make sure you don't flip this around. The P minus 2 has to be in the front part, meaning that if you move it over here, it should still read P minus 2, P divided by 2 minus L. It should still read like that if you flip it. Okay, next we have this last one as an example for what we're going to do. Solve y is equal to x divided by 3 plus 8 for this one, okay? So what we're going to do is we're going to solve it. So I'm going to write it down. Y is equal to x divided by 3 plus 8. I need to get rid of my addition first, so I'm going to subtract. Subtract 8. Subtract 8. Subtract 8. I don't know what y minus 8 is, so I end up with y minus 8 is equal to x divided by 3. We multiply both sides by 3. Why multiply by 3? Well, it tells us to divide. I know we typically don't see these divide ones much, but you got to remember that when you see x divided by a number, you need to multiply to get rid of it. And we do the same thing over here. And because we have two different terms, we need to use parentheses because we got to multiply everything by 3. Whole side gets multiplied by 3. So you end up with y, 3y actually, after distributing, 3y minus 24, because 3 times 8 is 24, is equal to x. And of course, you could rewrite that as x is equal to, remember what I said, whatever's in front needs to stay in front if you flip it over there. So now it's in 3y minus 24. If you got a minus 24 here, you got to have a minus 24 over here, okay? So that's how it works. I think this would be a great section for y'all to get some practice problems. So here are 3 problems that you guys should try to solve. Solve h is equal to kj. Solve it for k. Get the k by itself. Solve 5a plus 7 equals b. Solve for a. And this last one, 2/3 times m minus 5 equals n. Solve for m. All right. Pause the video if you need to write these down, and you might want to give yourself a little bit more room to solve these things out. Come into class, prepare to show your answers. Let's see who can solve these. All right, now we're going to move on to the next section. So if you want to pause and try to work these out on your own right now, that's great. Do that. If you want to finish taking the notes, we're moving on. So, boom, here we have section 7-8, simple and compound interest. Once again, this is more of an introduction to this section. But first, you need to write this down because you need to understand these vocabulary words, and we need this simple interest formula. So, simple interest. When you deposit money into a savings account, your deposit is called the principal. So basically, the money you start out with is the principal. The bank takes the money and invests it. In return, the bank pays you interest based on the interest rate. Simple interest is interest paid only on the principal. So it's interest that you only get paid for by how much money you put in at the beginning, type thing. And the formula is down here. You can use this to find the entrance. This is only finding how much money you make off of it, not how much you have in total. This is the money that you made off the money that you put in. You take the principal, you times it by the rate, and then you multiply it by the time that it's been in there. So, for instance, when an interest rate is a principal, blah, 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 the rate is per year. So you need to look at the interest rate. So it says like R is an interest rate per year, and t is the time in years. So here's what we're going to look at. We're told to find the simple interest rate, then find the total. So if I have, for instance, $200, I can say that I'm looking for the interest, right? So I'm going to put my I here. I equals 200, because that's the principal. The interest rate is 4%. And we need to write that as a decimal because we can't multiply by an actual percentage. So if you don't remember, a decimal, to turn a percent into a decimal, you write it like this, and you move the decimal basically forwards 2 places. So you end up with 0.04. Okay, that's it as a decimal. And then we times it by 2. Okay? And during this section, you will be allowed to use a calculator. So here's our handy dandy calculator. And if we type in 200 times, whoops, I put the 0.4 already. Put 200 times 0.04 times 2, we end up with 16. So the answer is 16. Now remember, we're talking about money here. So that's one answer is $16. That's how much you made off the interest after 2 years with $200. Not bad, because $200 really isn't that much in the grand scheme of money. But then we're also told here to find the total. What that means is how much money do you have in total, counting the principal and the interest? Well, that would be 200 plus 16 is $216. So those are our two answers. See that? Voila. Now, simple interest is okay, but where it gets really good is compound interest. And it gets a little bit more complicated too. So let's take a look at the compound interest. Compound interest is nice because it works like this. When a bank pays interest on the principal and the interest an account has earned, the bank is paying compound interest. So this is like over several years you have an account. So you originally put in like $1,000 and it gains some interest. And after like 5 years, the interest that it gains is like, $500 or something. That's a ridiculous amount of interest. But you get the point. Let's just say that it's $500 on 1,000. Well, every time that you get the interest, it doesn't just use the original 1,000. It will use the interest total. So it's like before how we had $216. That would be like doing it a second time and finding out, okay, well, what's the next year I'm going to get? If I have $216 in there, the next time I get interest, it'll be not $16, but it'll be like maybe $16.50. And the next time after that, it'll be like $16.75. And then it keeps increasing by a certain amount, okay? Okay, so here's the formula because it is kind of complex. But B represents the final balance. So this one is not finding the interest so much as it's finding how much do I end up with at the end of it all. P is the principal. R is the interest rate for each interest period. And N is the number of interest periods. So this is important to focus on. So for instance, here's another one. So we have $2,000 this time. It's at 2% compounded semi-annually for 2 years. Now, it might say annually, which means it happens once every year. Semi-annually, like a semicircle, is only half of it. So half of a year. This is compounding at 2% every half of a year, meaning it happens twice a year. If it happens in one half, the other half, that's 2 times a year. So in 2 years, how many times are you getting interest on it? Well, if it happens 2 times, semi-annually means 2 times in a year. So every year I'm getting it 2 times. So if I have 2 years, that means what? 4. Yeah, you're right, 4. So let's plug in these numbers. So B, my balance, is equal to P, which is 2,000. Put my parenthesis, put my 1, plus, what's my rate? My R, which is 2%, which convert that to a decimal is 0.02. Close that. And N is the number of periods. There's a total of 4. I know it says 2 years, but remember, each year it happens twice. So we get this. The number here changes based on how many times it offers. Like for instance, if it said monthly for 2 years, well, how many months are in a year? 12. And if you have 2 years, how many months do you have? 24. So we would have put 24 there if it had said monthly. All right, let's work this example out once again, grabbing our handy-dandy calculator, and we're just going to type in 2,000. We need to put parentheses. These calculators thankfully have parentheses, plus, put the 1 plus 0.02, close parenthesis, and we're raising it to a power by 4, and you can do that by pushing this little arrow button. I don't know if you guys can see it very well, but it's this little arrow button right here. Push that, and then put your 4. That means we're raising that to a power. All right, so what we now do is we hit the enter button, and we end up with a total of, the balance now equals $2,164 and about 86 cents, okay? You might have a little bit extra remaining, but we just need to chop it off because the rest doesn't count in the realm of money. Okay, so there we go. That's how you use it. I understand we just did one example of each, but like I said, this is just an introduction. If you don't understand something, please go back and watch the video carefully over some parts. Maybe go in the textbook and practice a few problems yourself. And don't forget, I did give you 3 practice problems for transforming formulas. Go back and try those if you haven't already. I will see you in class.